Module 2 Object-Oriented Programming Concepts in OO Basic 2. 1. Introduction to Classes, Objects, and Methods. Let's start with the fundamental idea behind object-oriented programming. Classes are blueprints for creating objects. They define what data an object can hold, variables, and what actions it can perform, methods. Objects are actual instances created from a class. They hold their own data and can use the methods defined in their class. Methods are functions inside a class that define behaviors. Think of a class as the plan for building a house, and an object as the actual house you live in. You can have multiple houses from the same plan, each painted differently or furnished differently, but all based on the same blueprint. In OO Basic 2, you'll use these concepts to model real-world things in your programs, making them more organized, reusable, and easier to maintain. 2. Creating object and calling methods. Once you define a class, you can create objects from it using the new keyword. Example scenario. Class, car, with properties like color, brand, and speed. Object, my car, a red Toyota Corolla with a top speed of 180 km per hour. When you have an object, you can call its methods to make it do things. If car has a start method, you can call my car start to simulate starting the car. This approach allows your program to mirror real-world entities and interactions. 3. Creating classes with methods, instance variables, and properties. In OO Basic 2, a class can have instance variables, variables that hold data specific to an object. Properties, special members that look like variables but actually use getters and setters to control how values are retrieved or updated. Methods, functions or subroutines that define object behavior. Example. A student class could have instance variables, name, ID number, GPA. Properties, name, read/write, GPA, read-only. Methods, enrolling course, display info. This structure encapsulates data and keeps your program logically organized. 4. Understanding scope and access levels. Scope determines where a variable or method is accessible within your program. In OO Basic 2, scope is controlled using access modifiers. Public, accessible from anywhere. Private, accessible only within the same class. Protected, accessible in the same class and its subclasses. Friend, accessible within the same project but not from outside code. Choosing the right access level is important for data security and program integrity. For example, you might keep a bank account balance variable private to prevent unauthorized changes. 5. Instance variables versus local variables. Instance variables are stored as part of an object and persist for the object's lifetime. Local variables exist only within a method and disappear once the method finishes running. If you have a variable that needs to store a student's GPA for as long as the student object exists, make it an instance variable. But if you only need a temporary counter while calculating something, use a local variable. 6. Using constructors to initialize objects. A constructor is a special method that runs automatically when an object is created. It's used to initialize the object's instance variables. Example, if you create a book object, the constructor can immediately set its title, author, and price so the object is ready to use right away. In OO Basic 2, constructors have the same name as the class and don't return values. You can also have multiple constructors, constructor overloading, for flexibility in object creation. 7. Value types versus reference types. This is an important concept for memory management and behavior. Value types store their actual data directly. Examples include integers and structures. When you assign one value type variable to another, you copy the value. Reference types store a reference, or pointer, to the data. Examples include arrays and class objects. Assigning one reference type variable to another means both variables point to the same data in memory. This difference explains why changing an object in one place might also affect it elsewhere in your program. 8. Creating constant members. Constants are values that do not change during program execution. In OO Basic 2, you can create constants. At compile time using the const keyword. At runtime using the read-only keyword, the value can only be set in the constructor. Constants are useful for fixed settings, like max speed in a car simulation, where the value should never change once defined. 9. Using the Object Browser in the .NET Framework class library. The Object Browser in OO Basic 2 and other .NET-based languages is a powerful tool for exploring the classes, methods, and properties available in the .NET Framework. It's like having a giant catalog of all the built-in functionality you can use. For example, you can look up the string class to see all the methods for manipulating text. Learning to navigate and read the Object Browser will save you time and expand your programming capabilities. 10. Declaring methods with parameters. Methods often need extra information to do their job. This is provided through parameters. For example, a print message method might take a parameter message text to know what to print. Parameters can have default values, optional parameters, different data types, strings, integers, etc. You can also use byval or byref to control whether the method gets a copy of the value or a reference to it. 11. Shared class methods versus instance methods. Instance methods require you to create an object before calling them. Shared methods, declared with the shared keyword, belong to the class itself and can be called without creating an object. For example, math_sqrt is a shared method. Student.displayInfo is an instance method. Shared methods are useful for utility functions that don't depend on object state. 12. Subroutines versus functions. In OO Basic 2, subroutines, perform actions but don't return values. Functions, perform actions and return a value. If you just want to display a message, use a subroutine. If you need to calculate and return a GPA, use a function. 13. Passing arguments, by value and by reference. When you pass a parameter by val, the method gets a copy of the value. Changes don't affect the original variable. When you pass it by ref, the method can change the original variable's value. Use byval for safety when you don't want the method to alter the original data, and byref for efficiency or when you need the method to update the original. 14. Method overloading and optional parameters. Method overloading means having multiple methods with the same name but different parameter lists. This allows for more flexible use. Optional parameters let you call a method with fewer arguments. If you omit some, the method uses default values. Both techniques improve code readability and usability. 15. Recursion and its uses. Recursion is when a method calls itself to solve a smaller part of a larger problem. It's powerful for problems that can be broken into similar subproblems, like navigating folders, solving puzzles, or calculating factorials. However, recursion should be used carefully to avoid infinite loops or excessive memory use. 16. Scope rules recap. To wrap up scope. Local variables exist only inside a method. Instance variables exist as long as the object exists. Shared variables exist for the lifetime of the program and are tied to the class, not an object. 17. Advanced constructor usage. Beyond simple initialization, constructors can call other constructors, constructor chaining. Contain logic to validate parameters before creating the object. Set up dependencies or resources needed by the object. Module 2 Summary. In this module, we explored classes, objects, and methods. How to create classes with instance variables, properties, and methods. Scope, access modifiers, and the difference between instance and local variables. Constructors, constants, and the .NET Object Browser. Among others.